All right, this one's a doozy. So, I'm going to ask you to watch this one before class and then watch it again with an instructor in front of you. And this is a bookkeeping type proof. So, it's not in your book as bookkeeping type proof, but that is what this is. So, let A and B be sets. I'm going to show that A intersect B is A if and only if A is a subset of B. I used the symbol without the less than or equal sign right here. In class, I've just used the subset symbol. Your book is very consistent of using subset and allowing for equality. It's kind of like less than or equal. One set is less than or equal to the other. One set is inside and could be equal to the other. By the way, Dr. Williams picked this one. I just want full disclosure as you're listening through this, but you'll be glad of it because this shows you what's really important is bookkeeping type proofs, which you do see a lot of in real analysis, which makes it really difficult if you're not into bookkeeping because then those proofs you can get tangled up in quite a bit. So if and only if seems such a little cute thing. Oh, if and only if, but it's actually not cute. What it really means is that you've got two proofs to write. So anytime we see if and only if, we have to have a collective class grown because that means we got double the amount of work. So what do I mean by this? Just a shorthand way to write down that I've got double the amount of work. It means that I take the first part of the statement, A intersect B equals A, and I'm supposed to show that A is contained inside B, and I also have to show the other direction, which is called the converse statement. I've got to start with the back end, A is inside B, and I have to show that A intersect B is A. So Chase asked me the other day about symbol usage. And your book discourages you from symbol usage. And the reason the book discourages you is that people tend to overuse symbols, and because they overuse symbols, it makes the proof really hard to read. I am a symbol person, not a simple person. I'm a symbol person, but I do I think my symbol usage is a bit flamboyant in what I do. So uh, with with this, I generally don't like to rewrite the statement over and over again. So what I do is I indicate that which direction I'm going into the proof, if I got an if and only if, with the this is called an implication arrow. I'm going in the right direction and I put little quotes around it, indicating to the reader I'm going to the right direction. And if I'm going to the left direction, then this is what I'm doing. Not only that, so I would going back to the symbols, I would recommend just you're going to adopt your own style. You're going to get revisions and corrections from me and Dr. Williams. So in class and also with your homework. So with this, you'll kind of adjust a good appropriate use of symbols and good appropriate use of words. Some people are very good at writing something down and having it clearly articulated without using too many words. Um, and some people can use more words and not make it sound complicated. A perfect example of that is Colonel Roginski. He's one of the best writers I've ever met. He can make something sound like you just want to continue reading it. He does use more words than I do, and I go to him for help when I want to write something that I really want to win or get because he's such an articulate writer. So each person's going to have their gift and their style at writing. Mine is a minimalist writing style with flamboyance in it. Um, I do feel it reflects something on personality. So I do use symbols, but you'll see that I decode those symbols within the writing so that's not overwhelming. All right, another bad thing about this proof, we're not done. Two proofs. We've got two proofs here too. Whenever I have to show two sets are equal, it's an additional two proofs. I have to show, this is standard operating procedures. Whenever you show two sets are equal, you have to show that one set is contained in the other and vice versa. This set is contained in the first one. It's almost like you're showing one is less than or equal to the other and the other is less than or equal to the first. And the only possibility then is that they're actually equal. So a lot of like true proofs inside here. Okay, let's go. Let's get with the program. So I'm going to start with the first direction. I know that A intersect B is equal to A, and that I tend to write down what that means right away. Um, my students in the past didn't like doing that. They want to write down the know and show first, so they have something written on the page. You can do either one. You can go out of order if you want. Um, and we'll see what happens this semester, and we might adjust that proof sheet for the next class. So what that means is uh, two sets are equal if one is contained in one direction and vice versa, the second is contained in the first. Again, I got a problem here because I got a bunch of sets with lots of directions, not really sure what to do with my hands. Well, I have to write down what that means. Set containment means membership in one is membership in the other. So that means that if X belongs to the first set, then X belongs to the second set. And my second statement, if X belongs to the first set, then X belongs to the second set. That's what that means. Now I got something to work with. I've got two nuggets. What I'm supposed to show is that A is inside B, or show if X belongs to A, then X belongs to B. By the way, anything before the if and the then, even if you expand it in the part of the show, that's all no. Anything before the if and the then is always a no. So I know X belongs to A, and I'm supposed to show X belongs to B. So now that I've expanded everything out, if you're sitting at a desk, this is much easier. So you're going to write all this out. And what I used to do is I used to tape things around my desk so I could look up and see everything at the same time. And I didn't do this initially, but I eventually learned that I have to because I have to see things. And so I recommend maybe trying that. Like as you get out your nuggets and as you really define what you have to show, that you tape it up around your desk so that you can see it as you assemble your proof. I start out with let X and A. I state to the reader that I'm going to show X's and B. I do that for myself and the reader so that I know where I'm going to. By nugget 2, if X belongs to A, then X belongs to A intersect B. So I'm just going to pull that nugget 2 down. By definition of intersection, X belongs to both A and B. I'm exactly at my show. Therefore, I've just demonstrated X belongs to B. That's what I was supposed to show. So I took out the underlines and everything. This would be a proof that Dr. M would be proud of. And I'm going to actually rewrite the whole proof at the end so you can see what should be turned into Dr. M's class because she doesn't have proof guides and no notebooks. She just wants to see the finished proof. What should a polished proof look like? We're going to do that right at the end so that you can see all of it together. But this is pretty much the proof. You want to see all the nuggets and scratch work. Right, so I'm done with one direction. Now I have to show the other direction. If A, so I just copied and pasted that statement. If A is contained in B, then A intersect B is equal to A. So A intersect B is what I know. I like to expand that out right away. That means that if X is in A, then X is in B. That's my nugget. What I have to show is that A intersect B is equal to A. That means I have two things I must show. I have to first show A intersect B is contained in A, and A intersect B, and A is contained in A intersect B. 2.1 means I have to show that if Y belongs to A intersect B, then Y belongs to A. And I'm using a different symbol than X because I've abused X enough. Now I have some more no and shows, so I can pull out the no, and that's what I have to show. So let me start with just 2.1, and we'll deal with 2.2 later. So if Y belongs to A intersect B, then Y belongs to A. That's what I have to show. And I pulled out my nugget. That was my given. So I have everything assembled at the top. So I start out with Y is in A intersect B. I'm going to show Y is in A. Y belongs to A intersect B means that Y belongs to A and Y belongs to B. See me pulling the definition, going right back to the definition every single time. Well, if I'm right where my show is. Y is supposed to be an A. I had a bad feeling here that I did the easy side first. So now I got 2.1 done. Now we got to go to 2.2. A contained in A intersect B means that if Z belongs to A, then Z belongs to A intersect B. I've got a new know and new show. So if Z belongs to A, then Z belongs to A intersect B is what I'm supposed to show. I still have my nugget 1 up there that I can use. So I start out with Z and A. I'm going to show Z belongs to A intersect B. By my hypothesis or my know, Z belongs to A implies Z belongs to B. That's nugget 1. So that means Z both belongs to A and B at the same time. By definition of intersection, Z belongs to A intersect B, which is where I'm supposed to end up. All right, so that's everything expanded in pieces. It is bookkeeping. That's not what Dr. M wants to see. So what do we put in for Dr. M? She never sees any of the blood, sweat, and tears that you're going to go through. She only sees the polished proof. So here's how I would write the polished proof. I would take all my pages and notes and then assemble a polished proof that I'm going to turn into Dr. M. So assume A is intersect B is A. Look at my symbol here indicating to the reader that I'm going in the first direction. I'm going to show that A is contained in B. So here, although I've not rewritten the statement, the symbol saves that one word and it actually makes it easier to read, and I've delineated what I'm doing here. So the reader with that symbol knows what I'm doing. So it's not that I just use a symbol and just draw forward. So let X be an A. I need to show X is in B. So I'm not writing down all the directions that I've written down for my scratch work. By hypothesis, if X is an A, then X is an A intersect B. So X is also in B. So I indicate to the reader that I'm using my know right here. And I don't do more. It's clear that I ended up where I'm supposed to end up. And so now let the reader know I'm going in the other direction. Now assume A is contained in A is contained in B. I'm going to show A intersect B is equal to A. So I let the reader know that I'm going to go set containment this direction first. So this is the quote. First, I will show if X is an A intersect B, then X is an A. So I'm using these kind of not as shorthand symbols, but more to let the reader know where I'm going with it. So X belongs to A intersect B means that X belongs to A and X belongs to B. So X automatically belongs to A. The other direction. Now we'll show that if X belongs to A, then X belongs to A intersect B. If X belongs to A, then X belongs to B by the hypothesis, and I rewrote the hypothesis because I'm pretty sure by this time my reader's forgotten all about it. So X belongs to A and B. This definition means that X belongs, by definition means that X belongs to A intersect B, and completes this very long proof. So I put some more symbols here because I thought it was a longer proof. All right, so the point of this is that you can take your style, whatever your style is, and explain it to people the way you want to. If it's too long, it's just as confusing if it's too short. I've not had too many students use too long of proofs. It's usually been the other way around. They have to be goaded into writing more. But I did have a couple times where I had really long proofs. One of them I never forgot was a lawyer who wrote, he was a lawyer just taking math classes for fun. He would give me 10 pages for one paragraph. And I just couldn't get him to understand that this is confusing and it's overkill. And I would mark it all up and say, you got to cut this back. And he'd say, but it's right, isn't it? Like, that belies the point because I have a Bachelor of Arts in math. Math is an art. We don't write 10 pages for something that should be a paragraph because it's confusing. And the whole idea is that you're articulating to the reader why something's true. I also had a colleague who loved case-by-case proofs. Everything was a case-by-case proof. And I had a professor that was much like me, like keep it short, keep it simple. So he did this long case-by-case proof, and I said, I think Andrew's going to mark you wrong. And he's like, well, I got it right. He said the same thing the lawyer said, got it right. Like, I still think he's going to be pissed off when he sees what you're writing. And sure enough, he got a ding right and left. And the reason was, I didn't understand it back then, but the reason was that if it's confusing to read, it's not right. It's not a good proof. Doesn't mean you wrote it well. The other direction, if you write too little, then you're asking the person who's reading it to guess what's in your mind. And that's not a good place to go when you're articulating something. They may not even know what's in your mind. And we're going to see that in class when we do peer reviews. You might not know what's in the person's mind. And if you don't know what's in the person's mind, you can't guess what's in their mind. And so, therefore, you need to fill in enough details so that you don't make them guess what's in your mind. As far as I know, there's no mind readers here. And so that's why we have to find that sweet spot. And that takes time. That's another one that just takes time. All right, we end this proof.